Sound wave looks kind of like this. What you need to do is you need to write down that sound is a compressional wave. That's key. Sound is a compressional wave. You don't need to draw any of these other pictures. Those are just there for your own enjoyment. Sound is a compressional wave. Now it's a compressional wave as opposed to a transverse wave. Transverse waves are the waves that look like this, the waves that have crests and troughs and all that kind of stuff like we talked about. Compressional waves look like the dominoes that you've been knocking down. So to draw one, we're going to draw it really strange. What I want you to do is, why don't you draw 5 lines, 5 vertical lines, like that, kind of close together. They don't need to be perfect at all. All right, now that you got 5 lines, let's skip out to like here or so in relationship to your page, and let's put 4 lines far apart. 2, 3, 4. I know it looks really strange. Now, if you don't have exactly 5 lines, it's fine. If this is not exactly 4 lines, that's fine too, not a big deal. Now that you have that, why don't you put 4 more lines close together? So I'm going to go 1, 2, 3, 4. Now there are actually 5 there because I included the other one, but it doesn't matter if it's 4 or 5 to get the general gist. I added 4 to the one.
So it's 5, 3. It's 5, 3.
5, 3, 5 works. That works out well. All right, so if you got any more room, throw a couple more on that are far apart, and then we're good to go. What you need to be able to see is that you have an area on your paper where the lines are close together, and you have an area where they are far apart. If you have that, then you have everything you need to be able to label these parts of a compressional wave. The way my picture is drawn, this would kind of like represent 2 sound waves or 2 impulses of air that you could be heard. For example, like if I clapped twice, boom, boom, it might look like this. Okay, an area of air I've compressed is pushing this way, and then another one is pushing this way. Your domino lab represents just 1 sound wave moving through. We have parts of this wave, just like we have crests and troughs of transverse waves. We have areas where the matter in the wave is compressed. And what's kind of nice is we call it something that makes sense. We do call it the area of compression.
Oh, yeah.
That makes a lot of sense. That's one where kids are usually like, okay, that's pretty easy. So on my wave, I have 2 areas of compression. We've got one, and the other one is hanging out over there to the right. Now, that one makes sense, the area of compression. Over here, we have an area of spready outiness. Okay, that's not what they call it. Too bad they don't. That would make a lot of sense. Some kids are like, oh, I know, maybe it's the area of decompression or something like that, the area of spread outness. They actually call it the area, and what kind of stinks is it sounds similar to a word that you've used when you've been talking about electromagnetic energy. It's called the area of rarefaction. Here's how I remember it. The particles are pretty rare in here. Do you know what I mean? You don't see them very often. So here we got a lot of lines in the area of compression, and then here we have a few lines in the area of rarefaction. So like you have crests and troughs in a transverse wave, you have areas of compression and rarefaction in a compressional wave. That's a weird word. Sorry about it if you don't like it. What'd you say?
Is that all one word?
Yep, that's one word, rarefaction. Now, a wavelength. Sound has wavelengths. It's what's responsible for things like pitch that you hear, whether something is high-pitched or low-pitched, and that's something we're going to talk about tomorrow that kids really like. But if you go all the way from an area of compression to the next area of compression, that would be considered one wavelength. So in a transverse wave, the distance from crest to crest will be a wavelength. Here, the area from an area of compression to the next area of compression is considered the wavelength. And I've got a bonus sticker for anyone who remembers what that symbol is called. Oh my gosh, look at that finger. Do you know it?
I remember what it looks.
You remember what it looks like? Do you remember what it is called? I'm just curious. Oh my gosh, I got 2 of them over there. All right, since I have 2 people that are vying for this bonus sticker here, I'm going to hold 2 stickers, and I'm going to make you say the word at the exact same. Oh no, I got you 2. I'm going to make the 3 of you say. Are you in on this?
Yeah. What?
Okay. Whoa. I want to know what that symbol is called. what that symbol is actually called. All right, so you're out. You got 3 people. 3 people. On the count of 3, you will all say it at the exact same time. You have to be the judge. See if they say it. Oh, you're out? Are you out? Okay, so you're in. Are you in, Treya, still? Okay, on the count of 3, the 2 of you are going to say what this symbol is right here, and you listen to her. I'll listen to him. All righty? 1, 2, 3.
Purse.
Neither of them. I'll give you.
Greek thing.
It is a Greek thing, and it. You know what? I always remember it by starting with Mary had a little.
Lamb.
Oh. Sheep.
Mary had a little sheep. We need to go back a couple grade levels there. Mary had a little.
Lamb.
What?
Lambda.
Lambda. Excellent. Works out absolutely perfectly. Great. Believe it or not, that is our journal entry. So that's the first part of the journal entry that we need.